In lesson 12.2, we're basically going to be doing the same things we did in 12.1, but now they put in story problems. And so it's exact same things that we learned in 12.1, but in the context of a story problem, which some people find to be confusing. So let's take a look at this building. We notice here that we have a 20-foot ladder, and it's placed against a building that makes an angle of 55 degrees with the ground. Part A, at what height does the ladder touch the building? So I'm looking for, in part A, the H. I notice that I have a 55-degree angle, and I notice that I know the ladder's length is 20. So I have the angle, the side opposite to that, and 20. What this means is that I set up an equation based on those green highlights, and since I have an angle, the opposite, and the hypotenuse, I know that means I use sine. So the sine of 55 degrees is equal to h over 20. That's this equation set up over here highlighted in green. Now, what I should do next is I type in to find out what the sine of 55 degrees is, recalling that I should be in degrees. So the sine of 55 degrees, if I type that into my calculator, I end up with 0.8192. And I see that in the equation that's next to the highlighted green one, or in other words, highlighted in yellow, has the variable on the top. So what I do is I multiply the 20 and the 0.8192, and as a result, I get 16.38 feet. Or in other words, that's the height that the ladder is lying up the side of the building, or it reaches to a height of 16.38 feet. In part B, they ask for something different. In part B, they're asking for how far away does the base of the ladder reach from the building. So this time, when I'm talking about this in part B, I'm looking for the letter B. So I have that I'm searching for letter B. The angle is still the 55-degree angle, and I still know that my height of my ladder, or that the length of my ladder is 20 feet long. I think it's in feet. Let me just see. Do they tell us? Yeah, feet. So now I have an angle, 55 degrees. I'm looking for the adjacent side B, and I'm given the hypotenuse 20. Adjacent and hypotenuse means I'm working with cosine. So as I look at doing this problem, I have to use the cosine of that angle 55 degrees equals b over 20. That's highlighted in the orange down below. I type in the cosine of 55 degrees, and I find out that the cosine of 55 degrees is 0.5736. So now, highlighted in the brown is the equation 0.5736, which was the cosine of 55, equals the b over the 20. Again, I notice that my variable is on top of the fraction, so I take the 20 and I multiply it by the 0.5736. This yields an answer of 11.47 feet. That means that the base of the ladder is 11.47 feet away from the building. In our next problem, we have a tree, and during a violent windstorm, the tree is broken by the wind. The top part of the tree is bent over and touches the ground 14 feet from the base of the tree. If the top part of this tree makes a 35-degree angle with the ground, how tall was the tree before it was damaged? So now, what we're going to do is we have to find two pieces. The piece where it broke and it's still in the ground, and the piece that fell down. So we're finding two parts in this problem to solve the final thing. In the first part, let's take a look at finding side B, which is actually the trunk that's still coming out of the ground. In this particular part, if I look at what's going on, I have an angle of 35 degrees. I'm searching for the side that's opposite to that 35 degrees, and I know that the distance on the ground happens to be 14 feet. So what I do is I say that I have an angle, the side opposite to angle involved, and the adjacent. That means that I'm using the tangent function because tangent's opposite over adjacent. So I set up my equation, tangent of 35 degrees equals b over 14, highlighted in yellow. After I do that, I type the tangent of 35 degrees into my calculator, and I find out that's 0.7002. I now have my next equation set up, which is that 0.7002 equals b over 14. And since my variable is on the top, I multiply the 14 by the 0.7002, and I find out that that b, or the trunk part, is 9.8 feet. Now, that part, right now, is only talking about the trunk and the ground. So I also have to find the h. Now, to find that h, what I notice is I still have to use that 35-degree angle that's with the treetop and the ground, but this time I have the adjacent side to that, and I'm looking for the hypotenuse. So when I have an angle and an adjacent side and a hypotenuse involved, that means that I'm dealing with the cosine function. And the cosine function you can see on the right side of our slide here is 35 degrees, so cosine of 35 equals the h over 14. And actually, that is definitely not correct, because the adjacent should be on the top. So, let me rewrite that, my apologies. Let's cross that stuff off. And here's what it should look like. It should say the cosine of the 35-degree angle is equal to the adjacent side, 14, over the hypotenuse, called h. So I type in the cosine of 35 degrees, and I get 0.8192, and this should be 14 over the h. And then, in order to find out my h, what I'm going to do is I'm going to take that 14, and I'm going to divide it by the 0.8192. When I do that, I find out that my h is equal to 17.09 feet. So now I have two pieces. I have the piece that was the trunk, which we saw was 9.8, and I have this piece that was my top that fell down, which is 17.09. In order to find my answer, I put those two pieces together. So I have 9.8 plus the 17.09 for a grand total of 26.89, and don't forget this was in feet. That was the total length of that tree when it would have been standing upright. In our next example, we see a hunter here trying to shoot a duck, and we want to know what's the shooting distance to a pheasant flying 35 feet above the ground if the angle of elevation is 60 degrees. So again, I look at my pieces. I notice that I have an angle of 60 degrees. I notice that the side opposite is 35, and I know that the hypotenuse is what we're looking for. So opposite and hypotenuse being involved with reference to an angle means that I'm dealing with the sine. So I set up my equation when I do this to say that the sine of my 60-degree angle should be equal to 35 divided by h, or in other words, opposite over hypotenuse. I type in the sine of 60, and I get 0.8660 equals 35 over h. I notice that since my variable is on the bottom, I divide, or in other words, my h should be equal to 35 divided by the 0.8660, or h, in other words, when I make that division, is 40.41. And again, don't forget your labels. We were working in feet. So the shooting distance is 40.41 feet.